In nowadays, integral value like giving more restrictions is quite a obvious trick for JEE Advanced. So let's see how to solve this. Clearly alpha plus beta is 2p and alpha beta from this expression is c by a. That gives alpha minus beta whole square minus 2 equals alpha plus beta whole square minus 4 alpha beta minus 2, which is 8p plus 2. And similarly we can see alpha plus beta whole square plus 2 is nothing but 4p square plus 2. Now plugging this both value over here, we are getting 4p plus 1 over 4p square plus 2. So this is a usual routine. Now I want this to be integer. So let it be n, where n is just some integer. One way of playing with this is p is real, right? So now we don't have much freedom with n, but we have absolute freedom with p. Let's say if I keep p is 1.7574, of course it feels like n is not an integer. So we need to find all those p which might not necessarily be integer, because even if p is a fraction, let's say p is 1 by 4 or 1 by 2, it might give chances to be integer. Okay, so chances are there even if p is in the form of k by 4, k by 16, something will cancel and still we can find integer. So how to go about this? Now still we can sense a quadratic over here. So if we'll cross multiply, we'll get 4 in p square minus 4p plus 2 and minus 1 equals 0. Since p is a real number, so either n can be 0. Okay, so either n will be 0 or n not equal to 0. If n is 0, clearly the value of p that I'll get is minus 1 by 4. Okay, that is one of the possibilities. Let's talk about other possibilities when n is non-zero, when integer is non-zero. Then for this quadratic to have real root, we must have d value greater than or equal to 0, and which amounts to 4 minus 4n, 2n minus 1 greater than or equal to 0, which clearly translates to 2n square minus n minus 1 greater than, which clearly translates to this expression less than or equal to 0. And with a bit of factorization, 2n plus 1 into n minus 1 less than or equal to 0 gives us n is belonging between minus half to 1. Now since we know n is integer, so between minus half to 1, the only possible value that we can take is n equals 1. If I'll keep n equals 1 back in the equation, that gives simply n equals 1 gives us 4p square minus 4p plus 1 equals 0, which gives 2p minus 1 whole square equals 0. Correspondingly p equals half. So there is two solutions for this equations. Okay, the all real values of p is either p equals half or p equals minus 1. Question, and this is a easier problem first. So we'll do one tough, one easy. A and b satisfy this equation. We have to find the value of a and b. Now clearly a plus b whole square is not a square plus 2ab plus b square, but rather it will be a square plus b square plus ab plus ba in the matrix world. And if this has to be equals ab plus ab plus a square plus b square. So after this cancellation, we have ba and ab must equal. So this matrix must be commutative. Now for commutativity of matrix, simply I'll multiply AB and will equate to BA. And as you can see, the equation that will generate after multiplication, A minus 1 is A plus 2B, B plus 2 is minus A plus 3B. The third equation is 2A plus 3 equals minus 3, 2B minus 6 equals minus 7. So which gives equals minus 3 and B equals minus half. So xt and yt is given. So depending on t, we will get the coordinate. Let's say t equals 0, that will give x0, y0. So correspondingly, we'll have 1 and 0 as a point. So we have these 3 points, which is explicitly mentioned in the question. And we need to find, so for these 3 points, we need to find the area of triangle. Okay. Okay, so let's move to the next question. We have a real number t, x t, y t is given. So for t equals 0, we'll have x 0, y 0 is 1, comma 0. So at t changes, x t, y t keep on changing, right? So these vertices will keep on changing. Of course, for the particular location, let's say for t equal to 0, these three vertices will be fixed and centroid will be fixed. At t changes, centroid will move because triangle itself will keep on moving. We have to find the locus of centroid. So pretty straightforward question, but remember you don't have to do any calculation mistake. So what is x coordinate of centroid? Xc. Better I am writing x coordinate of centroid with xc, which is 1/3 of xt plus xt plus 1 plus xt plus 2. Now simply put these values in terms of t, and what we are getting is 7/12, 2 to the power t plus 1 plus 2 to the power minus t minus 1. These steps are obvious because you can replace t with t plus 1 to get xt plus 1. It's 2 to the power t plus 1 plus 2 to the power minus t plus 1. T will be replaced with t plus 1. Okay, and clearly 2 to the power t we can plug out, and similarly from 2 to the power t plus 2. Now since y coordinate of centroid is still 1/3 of yt plus yt plus 1 plus yt plus 2, and similarly just by plugging this value we are getting 7/12 2t plus 1 minus 2 to the power minus t plus 1, except of course 0, and its reciprocal is greater than equal to 2 because for 0 it's not different. Okay, so 2 to the power t will always be non-negative, so 2 to the power t will be greater than 0, right? Similarly 2 to the power minus t will also be greater than 0, as you can see from the graph. So I can clearly see like this expression is definitely more than 7/6 if I am applying MGM, right? Similarly, for the values of y, we can't conclude as of now, although we can find the range as well. So now xc and yc, it's quite symmetric. So xc plus yc is nothing but 7/6 2 to the power t plus 1 if we add both equations, and xc minus yc, which can be easily eliminated, 7/6 2 to the power minus t plus 1. If just I multiply these two equations, so if I multiply this, we are getting xc square minus yc square equals 49/36. Now is there any restrictions on the x? Of course yes. So xc is more than 7/6. So the entire locus will be this hyperbola provided with this restriction. Okay, so this was also a straightforward question, but nice at least to do calculations. Moreover, the statement of question was very fanciful. Let's move to the next question, and this is nicely from the vector world. Given 3-point origin A and B, the point P is moving on a plane satisfying PA dot PB. Okay, this is dot product plus 3 times OA dot OB equals 0. Find the locus of P and hence finds maximum value of magnitude of PA into magnitude of P. Okay, so let's solve this. Again, we can take point P to be x comma y. So we know what is PA vector. It's nothing but 1 minus x comma minus y. I and j I am just omitting for the sake of fast calculation. PB is minus 1 minus x I and minus yj. So I am writing a comma b is equivalently at ai plus bj. This is a short hand notation of ordered pair that I'll be using. So the inner product PA dot P minus I dot I. Now according to the condition of the problem, their summation should be 0. So simply if we plug this information, we are getting x square plus y square equals 4. So hence locus is a circle. Second is find the maximum minimum value of PA into PB distance. So what is PA distance? PA magnitude is 1 minus x whole square plus whole square root, right? And PB 1 plus x square plus y square root. So PA into PB whole square, it will be better to calculate. 1 minus x square plus y square into 1 plus x whole square plus y square. And this gives you 1 plus x square plus y square minus 2x into 1 plus x square plus y square plus 2x. Since 1 plus x square plus y square, we already know x square plus y square is 4, so that goes to 5 minus 2x into 5 plus 2x. So which boils down to 25 minus 4x square. Now we know for a circle we have restriction on x, right? Because x can go maximum up to 2. So it's 2 comma 0 minus 2 comma 0, and so is y 0 comma 2 0 comma minus 2. So since mod x is less than equal to 2, so x square will be less than equal to 4. So x square is dancing from 0 to 4, right? So hence 4x square will dance from 0 to 16. Hence this quantity will dance from 9 to 25. Hence PA mod PB magnitude will dance from 3 to 5. The line of intersection of two planes. So we have got two planes. And clearly if they are if two planes are intersecting in a line, they cannot be parallel. Okay. So for a plane is characterized by normal vector n1 and n2, as we know. So here clearly n1 is not lambda times of n2, right? Okay, fine. Then the first portion is straightforward. Find the direction vector of line L. So direction vector of line L will be nothing in the direction of n1 cross n2. So that we can easily find. IJK direction 3D coordinate system. We have direction of first plane is a11, second is 1 minus a, and that gives us I times 2a minus j over a square minus 1 and k times minus a square minus 1, which is basically direction is minus 2a comma, you can multiply even with negative sign or with any lambda. So this is fundamentally direction of a line of intersection of these two planes. Direction we can quote in any direction, okay, this way, or maybe even magnitude we can multiply by lambda. It still gives a feeling of that. The second question is interesting, and that tells line L describes a surface as the real number a varies. So clearly if a is changing, the two planes changes, so their line of intersection changes. So if line of intersection changes in a space in 3 or R3, which is 3D, so it will create a kind of surface. If a line moves on a plane, it will give a planar surface. If it is in a space, it will give a surface. We have to identify that surface. And moreover, xy with the point of intersection of surface in the plane z equals t. So z equals t, as you know, z equals constant. Let's say z equals 1 will be some plane, right? So if that surface, whatever you are getting, okay, that surface is intersecting this plane, z equal to t, find the equation which gives the relation between x and y. So this is a nice insight question. We can now easily find the equation of line because we know there is a common point which is lying on both plane. Okay, so how to find the equation of line which is a part of both plane? Direction is already known to us. This is n cap, direction of line. So if we can find one point, it's done. And the best way to find the point is, as you can clearly see in the equation, minus 1 a comma a satisfy both equations. Okay, if I'll put x equals minus 1 and y and z as a, it satisfies equation 1 and equation 2. Definitely you could have kept z equals 0 also and check whether consistency is coming or not, or y0, x0, and solve two equation 2 unknown to get it. So this is a point and this is direction. So equation of line is x plus 1 by minus 2a equals y minus a by a square minus 1 equals z minus a by a square plus 1. Now clearly depending upon value of a, these lines keeps on changing. Okay, however denominator is 0, we'll set numerator to be 0. Okay, because whenever denominator is 0, numerator has to be 0, because 0 by 0 makes sense, can attain any values. Otherwise 2 by 0 will be not defined, right? But 0 by 0, it still tells, like the secret is not revealed. conclusion is still correct, but the secret is not clear. So from here, if we'll put like the xy coordinate of the point of intersection of the plane z equal to t with this line, with this surface actually, because you add a changes. This is not a single line, it's cascading of lines, so it will create a surface. Whatever surface it is, if I'll keep z equal to t, I'll get the x and y point of intersection. So put z equals t, we are getting x plus 1 equals t minus a into minus 2a, you can see from the equation, divided by square plus 1. Similarly, if I'll put z equals t, I'll get y minus a equals t minus a square minus 1 over a square plus 1. So it's not tough to get x minus 2at plus a square minus 1 by a square plus 1, and y value is a square minus 1 times t plus 2a by a square plus 1. Now once we have got these two values, clearly a square plus 1 is common there. We have a square minus 1 also, like, okay. So we can eliminate a easily from the one of the equations, and if we eliminate, we are getting x square plus, in fact you can eliminate a from these two equations, and we are getting x square plus y square. If you simply add, we have y equals a square minus 1 times t plus 2, yeah, correct. So this will give you how much? T a square plus 1, rest will get cancelled. Okay, so eliminating, we are getting this, right? So the curve that results from cutting the locus of line L by the plane z equal to t is a circle, basically. What is this? It's a circle centered at 0, 0, t, because the plane is cut at z equal to t. So on that plane z equals t, we are getting a circle there, right? The circle is centered at point 0, 0, but the height of the circle is t, and the radius of circle is nothing but root of t square plus 1. So let's say at z equal to 3, if you are cutting, so definitely you'll get this circle, right? At z equals maybe 1 by 3, you'll get a smaller circle. So at z changes, you'll get cascading of circles like this. Let's find the volume by z equals 0 and z equals 1. That can be a good question. Okay, so let's move to the third part, and we have to find the volume bounded by z equals 0 and z equals 1, and the surface obtained as t varies. If it is x equals 0, x equals 1, definitely still we can find, but it will be not so JEE flavor. Okay, so for z equals 0 and z equals 1, we know now this cone is cut by for z equals 0 and z equals 1, we know this cone is cut by two planes. So z equals 0, z equals 1. So we are getting this frustum kind of thing. Now what is the cross-section area? Cross-section area is pi r square, right? Cross-section area is pi r square. So we have pi into t square plus 1, and a small deft I can take dt. This is like a small cross-section. You take a volume element with dt, area of cross-section, times dt. dA times dt will give volume, and that integration has to run from 0 to 1, because we are adding this slice and accumulating this slice from 0 to 1. So 0 to 1 pi times t square plus 1 dt, and that gives you simply 4 pi by 3. So I hope you have enjoyed the question, and it was a nicer problem on 3D. Usually locus problem on 3D is very rare to find in books. Let's move to one more challenging one. Okay, fine. So let's hit this question. The last year JEE Advanced has already asked a problem based on x square plus y square plus z square equals 1 in 3D, that coupled with a plane. So basic test of and fragrance of a sphere was already injected. So in continuation of that, I have selected this problem to be solved. One observation you can see is clearly the z coordinate is 0. So this is sphere, this triangle OAB is placed on xy plane. So OAB. Now we have a sphere which is touching this. Of course, it's not a circle, because the cross section of a sphere that we will see will feel like a circle. Now it's quite easy to find the radius r, right? So r can be found as small r for this. Can be found out area of triangle by semi-perimeter. You can also do this by simple geometrical construction. Okay, so if we'll do area of triangle, we have 3 and 4. So half into 4 into 3. By this is 5. So perimeter is 3 plus 4 plus 5 over 2. So half this cancel. 12 and 12 by 12, that gives 1. So straightforward, a small r is 1. Now what is the distance between center of a sphere? So we know the center of a sphere will definitely be, and the in center, the point. What will be this point calculation? Okay, so since r is 1, so of course the coordinate of this will be r comma r, which is 1 comma 1. So I know the center of a sphere will be somewhere 1 comma 1 comma z, right? So it will be definitely be the projection of center of a sphere on the xy plane will be the in center of this sphere. So now we know distance between center of a sphere 1 z 1 because it's r comma r. Hence the center of the sphere will be 1 comma z because the projection of center of a sphere on xy plane will directly be in center. You can clearly see the symmetricity case. Now we know at least one point we know on the sphere. Let's say this point. So what is the coordinate of this point? It's nothing but r. So it's r 0 0 in 3D space, which is 1 0 0. So now we have a sphere whose center is known to us, which is 1 1 z. We have a point on the sphere 1 0 0, and the radius of a sphere is known, which is 2 according to the given question. So that directly gives 1 square plus z square equals 2 square plus z equals root 3. So hence center coordinate of a sphere is 1 comma 1 comma root 3. Now the of course question can be made more interesting JEE type. After this calculation, they'll ask you like there is a variable plane, maybe x plus y, minus z equals lambda, which is passing through the center of a sphere, and find the value of lambda. So just we'll put the value 1 plus 1 minus root 3 equals lambda, and hence lambda will be 2 minus root 3. Okay, so this is how basically in set notation questions can be like made more interesting. I hope you must have enjoyed this problem session.